it, bring it, fade, watch it, turn it, leave it, stop, format it, touch it, bring it, fade, watch it, turn it, leave it, stop, format it, touch it, bring it, fade, watch it, turn it, leave it, stop, format it, touch it, bring it, fade, watch it, turn it, leave it, stop, format it. All right, welcome back for part 2 of I can use continuous compounding formula that allows one to compound interest every hour, every minute, and every second. Let's get into the next example. Okay, welcome back. So we introduced the compound interest formula for continuous interest. So this is the formula we're going to use for infinite compounding. And a cool way of remembering it is just think about this acronym PERT. PERT, P-E-R-T, where P is the principal, E is the, what is the number E? R stands for the rate, and T stands for time. All right, so let's look at a few ways that we're going to use this. Okay, so question number 3, totally unrelated to the formula, talks about limits. So let's think about what this is saying. It's saying that a given function f of x, and the function is 1 over 2 raised to the x power. Use the table to find the limit of f of x. So what does this mean? Okay, I gave you a table with the intention of you guys looking at the table and doing the following. What we want to do is we want to put this equation into our calculators, and after we get it in our calculator, we want to set x equal to 0. So here we go. I'm going to put 0 on my calculator. I'm going to store that under x. Very nice. And then I'm going to put the equation y equals 1 over 2 raised to the x power. Okay, there it is, easy peasy. And then I hit return. Okay, so I see that when x is 0, y is 1. I'm going to do that again. I'm going to store 10 under x. Store 10 under x. No, I didn't say that. And I think it would be great practice if you pause the video and get your calculators and do the same. Okay, by storing 10 under x and hit return, I see that when I put in the formula of 1/2 raised to the x power, what I get back is I get 9.765625 in my calculator. And what we have to do is we have to move that decimal point 4 spaces to the right. So here we go. 1 move, 2 move, 3 move, 4 moves. So this is what it's going to look like. Okay. Now if I do it again and store 100 under x, what I'm now going to get back in my calculator is 7.888860905 times 10 raised to the negative 31 power. Now, one way to remember scientific notation is to remember when I have 10 raised to a positive number, my number is getting smaller. When I have 10 raised to a negative number, the number is getting super small. Okay, so the end of this question can be summarized as this. As the value of x increases, the value of y of x, f of x, gets closer to 0. Which to say is it's getting smaller and smaller, but it will never get to 0. So we're going to say the limit is 0. All right, let's move to another similar question. Okay, all right, if my function is 2 raised to the x power, what's the limit? Well, I'm not being very creative. I'm just going to put in the same sort of table. Okay, all right, and again, when I store 0 under x, I will find out that I get back 1 for y. When I store 100 or 10 under x, I get back 1024 under Y. And when I store 100 under X, I will get back this huge number of 30 decimals, which I can't even pronounce. There's so many decimals. So the final answer that we're interested in is, as the value of X increases, the value of f of X increases without N. So we're going to say that the limit is undefined, because we can continue doing this over and over again. Take a look at question 5. In question 5, it says Eric deposits $47,000 at 5.0% interest, compounded continuously for 5 years. What will his ending balance be? And how much interest did the account earn? So we put our PERT formula to work, and what we see is, make that our principal, our E, raise that to the rate, multiply that by 5 because that's time. We see that we're going to have $6,043 in some sense as our ending balance, but we're asked to find out what the interest was. So we took our ending balance and we subtracted from our original balance, and we're going to see our interest is $1,343.98. All right, pretty straightforward. Let's take a look at 6. In question 6, we're asked to find a lot of information. We're asked to find our compounding on a monthly basis, a daily basis, an hourly basis, and a continuous compounding. So it's just really a matter of plugging in numbers, guys. Here's my equation for monthly compounding. By monthly, we're doing it 12 times. All right, and we get this total. Here's my compounding on a daily basis. By daily, we're going to do it 365 times. We see the numbers grown. And here's my compounding on an hourly basis. So how do I get my hourly basis? Well, 24 hours in a day multiplied by the number of days in a week, and we see our number grows even bigger. But obviously, our biggest number is going to be as a result of continuous compounding. And obviously, we talked about before, we want to make as much money so that our money works for us instead of us working for our money. So that should be your final answer. So real quick, 7, using the table of increasing values to find the limit of this function. All right, guys, this is no real secret what I'm going to do. I'm going to throw it into my graphing calculator, and I'm going to evaluate X. And I see as my X value increases, Y gets closer and closer to 5, but it never crosses 5. So I can say that the limit of this function is 5. And finally, number 8. To find the interest earned on $14,000 for 9 months at 3.25% interest, I'm going to use my PERT formula, put in my principal, put in my rate, my time. I got to put 9 over 12. I'm going to get this 14,000 back. I subtract that from my principal, and I see that my interest earned is $399.34. All right. So, gang, what I'm going to ask you to do now is to get your class work. Use the examples that you see that use your notes to complete the examples that I have for you. And if you need help, I'm after school or third period lunch. It'll be a great time to get some one-on-one time. All right, guys, be well.